Welcome back. This is Mrs. RRubright with Advanced Geometry. Today's lesson is 9.5, Apply Compositions of Transformations. A composition is just more than one, so two or more translations, reflections, rotations, any kind of transformation. So in this first example, we are finding the image of a glide reflection. A glide reflection is a translation and then a reflection. So in this example, A, B, C are at 3, 2, 6, 3, and 7, 1. And we are going to find the image after they are translated to the, if you're going negative, in the negative directions, to the left, everything I need in a box to the left, no? So you're going left 12, and you're going up and down nothing, because it's not affecting the y value at all. So we're just going left 12. So we're taking all of our coordinates, and we're sliding it or gliding it left 12. Going and taking our b, and our x value is subtracting 12. We're going from 6 to negative 6. 6 minus 12 is negative 6. 7 minus 12 is going to give you negative 5. Okay, so we're just sliding it over left 12. Then we're reflecting the x-axis. When we reflect over the x-axis, my x value stays the same, opposite y. Okay, count to the line, count that far away from the line. 1, 2, 3 to the line, 1, 2, 3 away from the line. Or just take your 3 and you make it a negative 3 because you're just changing the sign of your y. And you're graphing your next image. So we have our pre-image, our original. After we translate it to the left 12, we have our image, which is our prime. And then our image of our image, after we reflect it over the x-axis, is our prime, right? The image of the image. So we have our pre-image, we have our image, and then we have the image of the image, which is our prime. Suppose triangle ABC in example 1 is translated 4 units down, then reflected in the y-axis. What are the coordinates of the vertices of the image? So you can do this through graphing, but that takes extra time. Let's just think. If I'm just simply translating it 4 units down, that's only affecting my y. It is my x stays the same, and then y minus 4. So I'm applying this rule first. Then I'm going to reflect in the y-axis. So I'm going to draw myself a quick little cheat sheet. This is my y-axis, this is my x-axis. I'm reflecting over my y. I have the opposite x, same y. Opposite x, same y. And you can use x and y instead of a and b, whatever makes it easier for you. So we're doing both of these changes. We're doing this change first, then the next one. So we're going to translate first, down 4, then reflect. All right, so all I'm doing is taking my y values and subtracting 4. 3 stays the same. 2 minus 4 is negative 2. 6 stays the same. 3 minus 4 is negative 1. 7 stays the same. 1 minus 4. What is 1 minus 4? Good job, negative 3. All right, and then for our prime, now we are just simply going to reflect it over the y-axis. When we reflect over the y-axis, once again, you have the opposite x, same y. Negative 3, negative 2. What is my b prime? Guys, b prime, negative 6, negative 1 half, or sorry, negative 1. And my c prime, negative 7, negative 3, good. In the diagram, a reflection in the line K maps GH to G prime H prime. A reflection in the line M maps G prime H prime to G prime prime H prime prime. Also, HB is 9. And DH prime prime is 4. DH prime prime is 4. Name any segments congruent to each segment. Okay, so if this is 4, right? It is reflected over here. And this was a reflection also. So if this is 9, this is 9. Name any segments congruent to each segment. HG. What's congruent to HG? H prime, G prime, right? It was reflected, and then it's reflected again. So H prime prime, G prime prime. What about HB? HB and H prime B. And then GA. GA and G prime A, right? GA and G prime A. HB and H prime B. HG and H prime prime G prime prime. HG and H prime G prime. So everything we said. In the diagram, all right, so it's the same thing. HB is 9. DH is 4. Does AC equal BD? Does AC equal BD? Yes or no? Explain. What do y'all think? These are parallel. This is 90. So this is 90, right? You starting to know what's going on here? What do y'all think? Are these equal? Yes, they are. Because G prime prime, and H prime prime are perpendicular to both K and M. So segment BD and segment AC are opposite sides of a rectangle. So yeah, they are. They're congruent. What is the length of G prime prime? The length of this whole thing here. Well, we know that this is 9 and this is 9. We know that this is 4 and this is 4. 9 plus 9 is 18. 18 plus 8, 26. Good job. Graph RS from example 2. Do the rotation first, followed by the reflection. Does the order of the transformations matter? Explain. All right, so this is from example 2. So we have RS, and they said do the rotation first, followed by the reflection. All right, so if we rotate and then reflect, so they're saying rotate this and then reflect it, is this going to be the same as if we reflect and then rotate? Well, let's reflect and then rotate with it. So if I reflect this, I'm reflecting over the Y. And then do my rotation, it's not going to end up in the same space. We have to go back to example 2 to see what exactly they had said we were supposed to do. Where is example 2? I feel like I don't have example 2 before this. Interesting. Okay, but yes, the order does always matter. So if they say glide reflection, you always are going to translate before you reflect, unless they state otherwise. Use the figure below for exercises 5 and 6. The distance between line K and line M is 1.6. The preimage is reflected in line K, then in line M. Describe a single transformation that maps the blue figure to the green figure. How can I go from blue to green in one move? Anybody?
Rotation.
So he thinks I can just rotate it? Rotate it. I can translate it. So reflect and then reflect again, or just simply translate it. You're right. What kind of translation though? What is the distance between P and P prime prime? If you draw P prime, what is the relationship with line K? Explain. So if I'm translating this, What is my distance between P and P prime prime if this was, I believe, what did they say, 1.8? 1 point what? 6? What do y'all think? Anybody? You just double it. 1.6 times 2. Because you're reflecting and then reflecting again, so it's going to be a total of 3.2. Just double it. They're perpendicular. In the diagram, the figure is reflected in line K. The image is then reflected in line M. Describe a single transformation that maps F to F prime prime. So instead of reflect, reflect, what can I do? Instead of reflect, reflect, what can I do? Rotate. How many degrees? If this is 70, you're going to double it. 140 degrees will bring it over here. Instead of reflect, reflect, you double it. 140 degree rotation about point P. In the diagram at the right, the pre-image is reflected in line K, then in line M. Describe a single transformation that maps the blue figure to the green figure. So instead of reflect, reflect, what can you do? Rotate. How many degrees? 160, about point P. A rotation of 76 degrees maps C to C prime. To map C to C prime using two reflections, what is the angle formed by the intersecting lines of the reflection? What angle would be? So basically this is like saying, what is this angle? If I'm taking this and I'm reflecting it, I'm going to rotate it to here instead of reflect, reflect. What would it have to be if my rotation is 76 degrees? It is not 152. Let's look back. So here, the angle was 80 degrees, and my rotation was 160. If my rotation is 76, what is my angle? You divide by 2. Good job, 38 degrees. Be very careful with what exactly it's saying. That is everything on 9.5, applying compositions of transformations. Just remember, do the transformations in the order in which they specify. Thank you so much for watching. Subscribe to our channel and like the video. Have a great day.